Okay, for this last unit in geometry, we are going to be doing some review of some big topics, and this week is focused on factoring. So in this lesson, we're going to talk about most of the types of factoring. I'm going to give you kind of a few examples of each, and then we'll figure out what we do if they're all mixed together. So the first thing we look for is the greatest common factor. So number one, the biggest number that we can divide out of here is 4. We can take out 2 x's, and we can take out 1 y. And we do that, 8 divided by 4 is 2. We have 1 x left, the y's cancel. 12 divided by 4 is 6. The x's cancel, we have 1 y. Plus 24 divided by 4 is 6. We have 1 x and the y's cancel. Now you might notice, hold on. 12 divided by 4 is not 6, it's 3. I apologize. You might notice that these two could actually combine like terms, but that's not typically going to happen in a factoring problem. Okay, on number 2, the greatest common factor that you can divide into all 3 of those numbers is 6. For the a's, you can take out 2 of them. Remember, they each have to have that variable, and you can't take out more than anyone has. So this one has the least, that's how many you can take out, because this only has 2 a's to give. You can't take out more than that. You can take out 2 b's. 42 divided by 6 is 7, and then you get a squared b minus, and here, what we're taking out in this term, they both match. And so when it divides something by itself, you get 1. And we have to have that there because we should be able to multiply these back out and get the same answer. 48 divided by 6 is 8. And then we're left with an a and b squared. Okay. The first pattern that we have is difference of squares. So difference of squares, it has to be a binomial, and there has to be a minus sign, and we need to take the square root of both. So when that happens, we'll go straight to our 2 parentheses. On this one, the square root of x squared is x, so we have an x and an x. The square root of 16 is 4. One's a plus, one's a minus, and we're done. Same thing on number 2. So on this one, we're going to take the square root of both of them. So the square root of 4y squared is 2y. The square root of 25 is 5. One's plus, one's minus. We're done. Okay, let's see what happens on number 3. It looks weird, but it still fits our pattern. Go straight to our 2 parentheses. The square root of 1 is 1. The square root of 36a squared is 6a. One's a plus, one's a minus. All right, number 4. Now number 4, it doesn't fit our pattern because it's not a minus, and you have 2 options. Option 1 is that you could rewrite it, which is totally fine, but that only works if it's a binomial. If it's any other factoring problem, that leading coefficient is negative, you're going to have to factor out that negative first. So you could rewrite it, or you could factor out a -1. And since we're going to have to factor out the negative on all the other types, that's what I'm going to do this time, so you're always doing the same thing. So when I take out that -1, now it changes the sign, so I have positive 81 minus 49x squared. Okay, now when I rewrite this, the square root of 81 is 9. The square root of 49x squared is 7x. One's positive, one's minus. All right, this next pattern is cubes, and we did learn cubes. It just has been for a while, so it's hard to remember everything. So let's start by writing out what the pattern is. So if I have, let's use a different color. If I have a cubed plus b cubed, and I'm trying to factor out the first parentheses, I'm going to take the cube root of both, so it's going to be a plus b. My second parentheses, I'm going to square the a, get a squared, change the sign, then multiply the 2 things together. Then the last sign is always plus, and then I square the b and get b squared. Now there's actually 2 patterns, one for sum and one for difference, but you really don't have to memorize 2 patterns. Because if this was a minus sign instead to begin with, the first parentheses is the same sign, the second parentheses is the opposite sign, and the last sign is always positive. So looking at number 1, x cubed plus 8. Well, it fits our pattern. It's a binomial. We can take the cube root of everything. So the cube root of x cubed is x. The cube root of 8 is 2. And the sign stays the same in the first parentheses. Then to get the second parentheses, it's not going to be very similar like in squares. It's going to be different. So you square the x, get x squared, change the sign to a minus, multiply the 2 things together. The last sign is always plus, and so then we get 4. All right, let's try this again. Take the cube root of everything. So the cube root of 27y cubed is 3y. First sign matches. Cube root of 1 is 1. Now I'm going to take 3y and square it, so I get 9y squared. Change the sign, multiply the 2 things together. 3y times 1 is just 3y. The last sign is always plus, and then we square 1 and get 1. All right, let's see what happens on the next one. We know on this one that you can take the cube root of everything. The cube root of 125 is just 5. Over here, though, when we have the exponents, if you can divide them by 3, then you can take the cube root. So 6 divided by 3 is 2, and 9 divided by 3 is 3, minus, because the first sign matches, the cube root of 125 is 5. Okay, now we need to square this first part. So if I am squaring x squared, I'm taking a power to a power. And when I take a power to a power, I multiply, and so that's going to give me x to the 4th. Same thing with y to the 3rd, but now I have y to the 3rd raised to the 2nd, so that's 3 times 2, which is 6. So I have y to the 6th. Change the sign to plus. Multiply the two things together, so you write the number and then the variables in alphabetical order. The last sign is plus, and then you square the 5, which is 25. Okay, let's do that again on the next one. So the cube root of 8y cubed is 2y. First sign matches as a plus. The cube root of x to the 12th. Well, you're going to divide the exponent by 3, so 12 divided by 3 is 4, so I have x to the 4th. Now we got to square 2y. That'll give us 4y squared. Change the sign, multiply the two things together. We write the number and then the letters in alphabetical order. The last sign is always plus, and then we square the last term. How would we square that last term? Well, we'd have x to the 4th squared, and we have power to a power. We multiply the exponent, so that means we're going to have x to the 8th. Okay, next one, leading coefficient of 1. Most people are pretty good at this. If it's a trinomial, it's got 3 terms. The leading coefficient is this invisible positive 1 at the beginning. So when that happens, we go straight to our 2 parentheses. We write an x and an x, because that would multiply back up to x squared. Then we need 2 numbers that multiply to negative 60 and add to negative 4. So this would be negative 10 and positive 6. Okay, over here, same thing. It's a trinomial with the leading coefficient of 1. I go straight to my 2 parentheses. I have an x and an x. My 2 numbers would be 7 and 5. If you took Algebra 1 here at Aquinas, they probably call this green light, because you don't stop, you don't do anything else, you just write your answer down. All right, now let's look at number 3. Number 3 is a little funky looking, but it's still the same pattern. Okay, on number 3, it's a trinomial. It has 3 terms, and the leading coefficient is still that invisible 1. So we are going to go straight to our 2 parentheses, and to get that x squared, we're going to have an x and an x, just like we always do. Now we're going to find 2 numbers that multiply to negative 14 and add to negative 5. Well, that would be positive 7 and negative 5. The problem is we should be able to multiply our answers back out to get the original. And if I multiply 7 times negative 5, that's going to give me negative 14, but not negative 14y squared. Oh, why did I say negative 5? Negative 2. Okay, that's going to give me negative 14, but not negative 14y squared. So what I need to do is add a y. Okay, so how does that work? Now if I multiply these, I'm getting negative 14y squared. That's what I need. If I multiply x times x, I get x squared. That's what I need. It's the middle term that people question. Well, to get that middle term, I'd multiply these 2 things together, which is 7xy, and I'd multiply these 2 things together, which is negative 2xy, and if I added those together, I would get 5xy, which is that middle term, right? Now, my answer is only the blue part, but I was just showing you why it does work. Let's take a look at this on number 5. Okay, 4 happens to be the exact same as number 3, so we're going to ignore it and skip to number 5. It's a trinomial with the leading coefficient of 1, so I'm going to go straight to my 2 parentheses and have an x and an x. Now, x and x multiplies back to x squared, and I need to get it to multiply back to x cubed, or excuse me, x to the 6th. So I'm going to put x cubed and x cubed. And the 2 numbers that multiply to negative 15 and add to negative 2 would be negative 5 and positive 3. So again, if you ask yourself, well, how does that work? Well, x cubed times x cubed is x to the 6th. Negative 5 times negative 3 is negative 15. That's all good. And to get that middle term, this would be negative 5x cubed and 3x cubed, which adds to negative 2x cubed, which is what we want. So it is correct. We don't need to do anything else, and what I have written in red is the final answer. Okay, let's try this again on number 6. So I'm going to go straight to my 2 parentheses. I'm going to have an x and an x, but instead of having x and x, I need to make it x to the 5th and x to the 5th to match this 10th. Okay, what multiplies to negative 16 and add to 6? Well, that would be positive 8 and negative 2. Okay, the last pattern is factor by grouping. So when I have 4 terms, I'm going to do what's called factor by grouping. So I'm going to start by looking at just the first 2 terms. And in the first 2 terms, I can take out a 3 and an x. Well, 6 divided by 3 is 2, and then I get 1x left over, minus 15 divided by 3 is 5, and the x's cancel. Whatever sign is the middle, I'm going to copy it straight down. Now I'm going to look at the second 2 terms. On these, I can take out a 2y, and that leaves me with 2x minus 5. I've done all the work, now we need to write our final answer. If you factored it correctly, and it is factorable, the parentheses will match. So I'm going to make one parentheses with what matches, 2x minus 5, and then a second parentheses for what they split, which would be the 3x plus 2y. Okay, let's try this again. So it's 4 terms, so I'm going to factor by grouping. So looking at just these 2 terms, I can take out a y squared, and I'm left with 2x plus 3. Whatever sign is in the middle, copy it down. Now I'm going to look at the second 2 terms. Here I can take out a 7, but it's actually a negative 7, and when I divide by a negative 7, it's going to change my sign. So negative 14 divided by negative 7 is 2x. Negative 21 divided by negative 7 is positive 3. So if I have factored correctly and it's factorable, my parentheses should match. So the first parentheses is 2x plus 3, and the second parentheses is what they split, which in this case is y squared minus 7. One more of these. Okay, next one. I'm going to look at the first 2 terms. I can factor out an a, so that leaves me with 3c minus 2d. Plus, the next one I can take out a b, and that leaves me with 3c minus 2d. Now that I've got it factored, I can just rewrite it as 3c minus 2d plus, whoops, not plus, apologize, parentheses a plus b. Okay, now the confusing part is figuring out what to do if it's all jumbled up. So we have this little chart to read off of. And I've given you this before, but I'll just show it to you again. So for each problem, you're going to start by figuring out what the greatest common factor is. Sometimes it'll have one, sometimes it will not. So after you look for the greatest common factor, then you have to decide if it's a binomial, a trinomial, or a polynomial. And for our cases, the polynomials are always going to be 4 terms. Once you decide that, if it's a binomial, it'll either be difference of squares or difference in sum of cubes. If it's a trinomial, the leading coefficient's either going to be 1 or not 1. Now in these notes, we're not doing any that are not 1. That's going to come next time. They're all going to be 1, but that's where it goes. And then if it's a polynomial, you're going to factor by grouping. Okay, we're going to do a couple mixed review together, and I'm going to go over a couple of them and see if that helps you get through these notes. Okay, on the first 2, whoops. Okay. The first thing you need to look for is the greatest common factor. And if it starts with a negative, we know there has to be greatest common factor, and it has to be, in this case, negative 3. So I'm going to take out the negative 3, and that's going to leave me with x squared minus 25. Now inside the parentheses, I have a binomial, and I can take the square root of both, so it's a difference of squares, which means I go straight to my 2 parentheses, and this is going to be x plus 5, x minus 5. Okay, over on this one, I look for a greatest common factor. They don't have one. It's a trinomial with the leading coefficient of 1, so I'm going to go straight to my 2 parentheses and write x and x. But that multiplies to x squared, and I need x to the 4th, so I'm going to write x squared and x squared. So now I'm looking for 2 numbers that multiply to negative 27 and add to negative 6, and that would be negative 9 and positive 3. X squared minus 9 factors further, and anytime we have an exponent that's not a positive, invisible positive 1, we have to check. This one factors further. It's a difference of squares. It's going to be x plus 3, x minus 3. This second one cannot factor further, and the reason is because it's got a plus sign, and squares only work if it's a minus sign, and we can't take the square root of 3, so it's not going to go further. So our final answer is this answer here that has got all 3 terms. And all I've done is rewrite that part of it. Okay, Next one. It's 4 terms. There's not a greatest common factor that you can take out of all 4, so I'm going to factor by grouping. Out of the first 2 terms, I can take out x cubed, and that leaves me with 2x minus 3. Plus, on the next 2 terms, I'm going to take out 8, and that leaves me with 2x minus 3. Okay, so one parentheses is 2x minus 3, the other is x cubed plus 8. Now this first parentheses, I'm not going to be able to take it any further because the exponent's invisible positive 1. But over here, this is a binomial, and this is not squares because I can't take the square root of anything, but I can take the cube root, so I'm going to use my cube pattern. So the first parentheses stays the same, 2x minus 3, and the second pattern, I'm using the cube. So the cube root of x cubed is x, sign stays the same, cube root of 8 is 2. Then I'm going to square the x and get x squared, change the sign, multiply the 2 things together, and the last sign is a 4. So this got rewritten as that, but this right here is my final answer. That's what you need to write to get full credit. Okay, let's take a look at number 4. On number 4, first thing we got to look for is the greatest common factor. And because this starts with a negative, you know there's got to be one. So on this one, my greatest common factor is 2x. So I'm going to take that out, and I'm left with x squared. 6 divided by negative 2 is negative 3x. And 56 divided by negative 2 would be negative 28. Well, now it's a trinomial with the leading coefficient of 1, so I'm going to go straight to my 2 parentheses. But notice I carried that greatest common factor just right along. The 2 numbers that multiply to negative 28 and add to negative 3 would be negative 7 and 4, and we're done. Okay, the other ones are filled out, but I'm just going to talk through them. On number 5, I factored by grouping. Okay, so the first 2 I took out the x squared, I'm left with x cubed plus 27. You have to factor something out, and for these second 2 terms there was nothing to take out except a negative 1, so I took out a negative 1, and I got x cubed plus 27. The x cubed plus 27 is a cube pattern, it factored further. X squared minus 1 is a squared pattern, and it factored further. Number 6, there's no greatest common factor, so I'm going to rewrite it x squared plus 4, x squared minus 4. The x squared plus 4, it looks like it factors further, but it does not, because with squares, it only works if it's minus. But over here, this one does factor further at x plus 2, x minus 2. Let's look at number 7. That was a trinomial with leading coefficient of 1, so I went straight to my 2 parentheses, but instead of doing x and x, I did x cubed and x cubed. The 2 numbers that multiply to 32 and added to negative 12 would be negative 8 and negative 4. The x cubed minus 8 fits my cube pattern, and so I used it there in the green. But the x cubed minus 4, the x cubed and the minus works, but I can't take the cube root of 4. It doesn't fit one of the patterns, and so it just stops there. Number 8, I had to factor by grouping again, and when I got done, I got x squared minus 9 and x cubed plus 8. The x squared minus 9 is the square pattern, factored that. The x cubed plus 8 is the cube pattern, and I factored it there. Hopefully this will help us.